All right. So you tell me if you have any questions. The first one, and you gotta have, you're gonna have to graph this out because you need to know which is your major axis. Your vertices lie on your major axis, and so do your foci. So the minute you find out where your vertices are, set up your parabola. Whoa. Something Mr. Parisi did to me yesterday messed me up because this hasn't been doing this. I gotta ask him, what does it do differently? So as soon as you do, you plot these points. As soon as you do and you determine your y as your transversal, start like this. A always has to be first. But now y is going to come first because that's the transversal axis. Start like this. You can determine your center. Take these out. Your foci will give you your C, which doesn't buy you anything here, but your A comes from your vertices, your C comes from your foci, and then you can use, oops, this is the wrong one. It should say A squared plus B squared. Okay, sorry, I just rearranged it. This is the one. There it is, A squared plus B squared, and I just transformed it. So you should use this one because what happens is you want to put the vertices outside of your foci points. So by adding them, it puts it outside of there. And you don't have to get down to the B, just get down to the B squared. B squared is all you need. And then plug in your B squared. Don't forget to bring your A down and square it. I always do this to myself first. I always put them down here so that I remember to square them. And if B squared, just cross that out and put your 12 there. See? Because your foci are out here. So the distance from your center to here and here is 4. C is the distance from your center to your foci. And in a hyperbola, your hyperbolas come out this way. Like the parabolas. They're two little parabolas, and your focus point of your parabola comes inside. Like if you think of it logically, if you're picking a focus point, you pick a focus point with something in your realm here, right? When you're in an ellipse, your focus point can't be outside of your ellipse, right? It has to be inside of your ellipse. In your parabola, hyperbola, has to be within that little parabola area. So your foci come inside this point. Okay. All right, again, start with where your vertices are. They give you your vertices. So your vertices, and you don't have to worry about your transversals. You don't have to worry about your asymptotes here. Just give me the equation. So you know it's the x. So the x comes first. Start like this. A is always first. It's the y and the x and the y that change. Okay, so start that. Again, your center is 0, 0, so this is knocked out. Your asymptotes. This time they gave you an asymptote. Now, an asymptote is just an equation of a line. And the only part of the line that helps you is your slope. Because that's the part we're looking for. So just pull out your slope. So your slope is the change of y over the change in x. So 5 over 1. Now, underneath your x happens to be where your a is. So you know what a is now. So you're just going to make a ratio to your y, which is your b term, your x, which is your a term, and you're just going to fill this in. So 5 over 1 is equal to b over, and a is 1, so therefore what is 5? What is b? 5. So now we know what b is. We don't need to know what c is. We just need to know b. If you want to leave it like this, with the 1 underneath it, that's fine. I tend to leave the 1 underneath it. But you don't have to. It looks a little weird without it.
How do you know, like, when you're doing a 5 over 1 equals 5 over, like, how do you know to do positive 5 instead of...
Well, you can do negative 5, because when you square it, it's still going to be a positive number. You can do negative 5. it goes both ways. The reason why that one's easier to do is because it's off the 0, 0, your intercept is 0. So either way, that one doesn't matter. What you're getting is something that's kind of long. It's going to be long this way. Well, it's going to cut across those points somewhere, you know what I mean. So it's going to be long this way. You can use a -5 because when you square it, it's the same thing. I just use the positive, it's easier. Make your life easy. Negatives, I usually find most of the errors, and even in myself, is with my negative signs. They just seem to get lost in the mix somewhere. When you put it a little too close to your equal, I put it a little too close to my equal sign. If I rewrite something and I notice the same thing with you guys, I'll draw a little arrow. You rewrote it and forgot to put the negative sign there. You multiply by a -1, one of the terms misses it. So here's your foci. So again, you're going to start with your y being first. This one's a little messy. Again, just keep going through it. Your A is always first. Start like this. These are the only formats you really have to know. Is your format of the ellipse, the hyperbola, and the parabola. Okay. So that distance here is 8. Because we found our center to be 0, 0. That distance is 8. That's your C. Now, C doesn't help you in your equation at all, but it can help you find another variable. Now, this one's a little tricky. So here's your problem here. My slope is a 4. 4 over 1. That's my change in y, and underneath my y is my A. Underneath my x is my b. Well, I know neither one of those. So I'm just going to cross-multiply what I have. I can't put anything in here. So I'm cross-multiplying and getting 4b equals a. Now, I do know my c. So if I'm using my a squared plus b squared, I'll write it a little bigger. I do know my a in terms of b. And I do have a b. Just call it b. So I can replace my a in terms of b. See it? You can only solve it for one variable. We know the c, but we don't know the a or the b. But this gives me what I can replace my a with in terms of b. So I'm going to put 4b squared in here, and don't forget to square the whole thing. b is b, and this equals 8 squared. So remember to square the 4 too. So I get 17b squared, and I divide by 17. Now I know b squared. However, I got to get to a. I got to get to a by itself. So you're going to have to take the square root of that guy and then multiply it by 4 to give you a. And then find your a squared. And don't forget to flip those fractions over. What you want to do is get rid of your denominator. So if you multiply this by 17, just put the 17 on top and multiply the top by 17. You have to take a fraction and multiply top and bottom by the same number. This gives you an equivalent fraction. So you do the same thing with these guys. We leave them down here when we're resolving a and b. But when we leave our final equation, we can't leave a fraction in the denominator. If you did, you lose maybe like a half a point. It's not a major. So you went through this whole mess. So don't forget, you can resolve the top, the 64, so resolve it. You don't have to resolve your denominators. This was a tougher one. Anybody get this before? No?
Would you put one like this on the top?
Actually, I almost did, and then I took it off. Just because this is going to be a tough week in terms of continuity. So if we looked at it today, we don't have to make it test on Wednesday. So I took it off. I just wrote the test yesterday, so it really is not so bad. I try to, the numbers might be a little big, like when you factor, but they're all factorable, nice numbers. They don't come out with fractions and weird things. Again, your vertices are off your major axis. They call it a transversal. That's your x. So start with your x term first. Now your center is off. So take the average of the x's, average of the y's, and find your center. From there, you can find your a, and they give you your foci. You can find your c. Use your equation and find your b. And again, all you need is b squared. I wouldn't go any further. All you need is the b squared. Because once you get here, you're going to have to square it again anyway, so just stop at the b squared. Good? Okay. Vertices again. You're off the y, so your y one comes first. This was nice, because again, it was just like the other one. You got your a, you got your c, and you can find your b. Just find your b squared. And these numbers kind of worked out nice. This should have been a nice one, right?
I never know what A, B, and C are.
Well, it's the same for the ellipse and the same for the hyperbola. A is the distance from the vertices. And try to think of it this way. The vertex is the main part of your whole thing, right? It kind of drives this and the ellipse as well. So A comes first. That's that guy. The B is the secondary one. He comes second. I need that to make my box. I need that to make my ellipse. C, he's kind of off to the side somewhere. He's a full side. Kind of think of it in order of importance. You know, anything that helps you think of something, make mnemonics for it, whatever helps you. I know over the years, it's funny, when I started teaching pre-calc honors, and I started teaching it, as I always taught up to algebra 2, and when I taught pre-calc honors, there were so many things that I remembered from when I was in high school, like doing this and saying, oh yeah, because I always came up with coin things to remember it. And my own kids, when I tell them my little corny things over the years, my boys were fine. My daughter was like, I don't want to hear that. Just tell me how to do it. But those are the things that stick in your mind. Okay, so this is a passes through. So we've got a set of vertices, and we're passing through the point 0, 5. This one's a little different. So vertices tell me, okay, I got a y, so I'm going to start with a y. And for some odd reason, my graph is off. The points are off, right? 2, no, I'm okay. Oh, that's a B, sorry. I thought that was a point. So here I am, 2, 3, 2, negative 3. Find your center. So your center is 2, 0. So just fill those parts in first. And I can get rid of that guy. Now, your distance here is A. So I know A. A is 3. Okay. So I fill in what I know. I'm up to this point now. I can't find B. I can't find C. But they gave me a point that it passes through. That means up here somewhere at the 0, 5, over here, is my point that passes through my hyperbola. So that has to satisfy this equation. So all I want to do is substitute in x and y. Substitute my x for 0, substitute my y for 5. And I want to solve for b squared. All I need is b squared. Because I got a. I don't care about c. So all I need is b squared. Just this guy. And then I'm going to put it in here. This I reduced. Oh, this is b squared. I reduced it here, so it's probably better to. This is reduced. So it's probably better to reduce it. Okay. A little messy. You're here with fractions. I get it. Find the common denominator. Multiply every term by the common denominator. Put it on top of every term. You okay?
Yeah.
Yeah. I got cough drops. Help yourself. Those are honey ones. They're good. 9's come out. I got a b squared. This guy b squared comes out. I'm going to multiply by 9. Like I did it over here. And that one stays there. So you can solve for b squared and just reduce. Questions?
Didn't you say that if the denominator is the same as the denominator?
If the denominator is the same, it's a circle. No, well, that's on the ellipse. If it's not equal to 1, the denominators can be the same here. Well, then who would be the main axis? I don't know. I never saw it be the same. Unless they specifically tell you what the transversal axis is. Probably could. But they're not the same. Because of this 4. It's really 9/4. Okay. Alrighty. And this is the last one. And again, you're dealing with your vertices first. Find out that it's an x. Set up your x. Put your center in there. I always start like that. Get rid of that part. You know A, so put A in there. Now, you have a slope. Obviously, go for the easier one. I'd go for this guy. So remember, your slope is change in y over change in x. So go to the y and take what's underneath it. Square root, it's b. Go to the a, Go to the x and take what's underneath that. That's the a. Now, what's b equal to? If these are 3, b is equal to 2. And now just plug the 2 in there. I know you guys see fractions and you can, but sometimes they work out pretty nicely.